so here's all you need to know. Right now we're looking at a neuron that's just at rest. So, you know, it's got dendrites going all over the place, and extending off the body is an axon, which is myelinated in this case by Schwann cells. In the space in between the myelination on the axon is known as the nose of Ranvier. Now, when the neuron is resting, the charge on the outside of the cell is positive and the charge on the inside of the cell is negative. And this is maintained by sodium-potassium pumps. In this case, potassium's orange and sodium is red. So 3 sodiums are being pumped out while 2 potassiums are being pumped in. That's how that charge is maintained, along with a couple other factors like chloride, phosphate, and sulfate ions inside. So that's the way a cell is when it's just resting. And then bam! Dendrite receives some stimulus. So as soon as that dendrite receives the stimulus, depolarization takes place and shoots its way down the myelinated axon. So now it's positive on the inside and negative on the outside. So sodium rushes in for this to happen, but closely behind the depolarization is repolarization. So potassium is rushing out and the sodium channels are closing, so the charge is maintained back to positive outside and negative inside. So the sodium-potassium pumps have taken a short break and now they're back and functioning again. So meanwhile, the end bulb has just been chilling, and it, like the neuron, is positive on the outside, negative on the inside. It's got the synaptic vesicles which hold the neurotransmitters and all that garbage. We already learned that. But when action potential, which has been working its way down the myelinated axon, reaches the end bulb, that sodium is going to rush in and reverse the charge in the bulb as well, and trigger calcium to come from the sarcoplasmic reticulum and open the synaptic vesicles for neurotransmitters, in our case, which is a muscle fiber, it's going to be ACH, to release into the cells. Now that the impulse has been communicated, the neuron needs to return to resting form along with the end bulb of the neuron. So sodium rushes out and calcium rushes back out. The charge goes back to positive on the outside and negative on the inside, and it returns to resting form. Now the myelinated axon is already back to resting form because, like we talked about earlier, repolarization was following closely behind the depolarization that was running through the axon, so that's already back in resting form. And there you have it.
You got me so crazy, baby.